Powerhead. The powerhead represents the most minimalist evolution of ballistic technology, designed for a world where traditional physics fails. In the underwater environment, the density of water is approximately 800 times that of air, making standard rifled barrels prone to catastrophic failure due to hydrostatic pressure. Engineers solved this by removing the frame entirely, leaving only a chamber and a spring-loaded firing pin mounted on a pole. This device is typically chambered for heavy-hitting rounds, like the .357 Magnum or even 12-gauge shotgun slugs. Unlike a conventional firearm, there is no rifling to stabilize the projectile because the engagement distance is exactly 0 inches. The lethal mechanism relies on a contact trigger system where the diver's physical thrust overcomes a 30-pound spring tension to strike the primer. Upon impact, the cartridge detonates directly against the target, releasing a massive volume of expanding gas into the wound channel. This gas expansion is far more destructive than the bullet itself, as it creates an internal pressure wave that can neutralize a 1,000-pound predator instantly. This tool remains the final line of defense for commercial divers and maritime security teams operating in high-risk environments. It is a raw, mechanical solution to a complex fluid dynamics problem, requiring zero maintenance and offering absolute reliability. AAI underwater revolver during the Cold War. The United States Naval Ordnance Station developed a specialized sidearm for SEAL teams, prioritizing stealth. The result was the AAI underwater revolver, a 6-shot weapon resembling a standard flare gun. Its technical genius lies in the ammunition, a unique .38 caliber cartridge housing a 4-inch steel needle to eliminate bubbles and the deafening underwater report. The cartridge uses an internal captive piston design. When the hammer falls, expanding gases push the piston, launching the needle and sealing the casing to trap noise and gas inside. This mechanical seal ensures no air bubbles reach the surface to reveal a diver's position during covert insertions. The steel needle launches at approximately 700 feet per second. Remaining stable in the dense medium, it provides a lethal effective range of 30 feet at a depth of 40 feet, where conventional bullets would stop within inches. The cylinder features oversized chambers to prevent salt water from interfering with the rotation and firing cycle. This firearm represents a masterclass in specialized engineering, sacrificing commonality for the absolute necessity of underwater concealment. SPP-1M. The SPP-1 is the definitive icon of Soviet naval Spetsnaz, prioritizing rugged reliability over complex internal mechanisms. This pistol appears as a cluster of 4 smoothbore tubes, reminiscent of a miniaturized anti-aircraft battery. It lacks a traditional magazine. Instead, operators manually insert a clip containing 4 long steel flechettes into the break action assembly. These specialized .177 caliber SPS rounds are nearly 5 inches long. Designed to slice through water like miniature torpedoes, the firing sequence utilizes a unique rotating firing pin that strikes a different primer with every pull of the double-action trigger. The weapon operates on a sliding scale of lethality dictated by hydrostatic pressure. At 16 feet deep, it maintains a lethal range of 55 feet, but this drops to only 20 feet at depths of 130 feet. The kinetic energy is sufficient to penetrate a double-layered vulcanized rubber diving suit and a 1-inch thick wooden plank behind it. This 4-barreled powerhouse remains in active service today, a testament to a 1970s design that has remained largely unchanged for decades. QSS-05. The QSS-05 is China's strategic response to the SPP-1, engineered for the smaller frame of Asian maritime operators, weighing only 1.3 pounds. This compact sidearm utilizes a 3-barrel configuration to reduce water resistance during rapid lateral movements. The firearm fires a 5.8mm DBS-05 dart crafted from high-density tungsten alloy for maximum kinetic energy retention. Despite its smaller size, this predator can punch through a half-inch thick layer of reinforced diving gear at 40 feet. A critical evolution is the use of advanced polymer coatings on the internal firing assembly to combat aggressive saltwater corrosion. Each barrel is independently sealed to prevent premature primer failure, a common issue in early underwater arms. Recoil remains manageable due to the low mass of the projectile, which exits the muzzle at 800 feet per second. In close quarters combat, the QSS-05 provides a reliable high-pressure solution, capable of neutralizing hostiles before they can draw a knife. It represents a shift toward lighter, more maneuverable weapons for modern naval special warfare. Heckler and Koch P11. The Heckler and Koch P11 is the most enigmatic sidearm in the NATO arsenal, shielded by decades of operational secrecy. Unlike Soviet counterparts, this German masterpiece utilizes an electronic ignition system powered by batteries concealed in the grip. The weapon features a 5-barrel assembly where each chamber is factory sealed with a plastic diaphragm to resist crushing deep-sea pressure. When triggered, an electrical impulse fires a 7.62 by 36 mm dart, shredding the seal upon exit. Because the barrel acts as the cartridge casing, no spent brass is ejected, ensuring silent and bubble-free operation. This logistical reality means soldiers cannot reload in the field. Once 5 shots are spent, the entire unit must return to the factory for refurbishing. This extreme engineering is why the P11 became the primary choice for Navy SEALs and British SAS during high-stakes maritime sabotage. Darts maintain a lethal velocity of 650 feet per second, reaching nearly 50 feet underwater. Above the surface, it functions as a short-range emergency pistol with a 30-yard capability, optimized for the silent, dark corridors of enemy harbors. CEB. The CEB emerged from Brazil as an ambitious attempt to challenge the established underwater arms race. This experimental pistol sought a middle ground between traditional rifled ballistics and fluid dynamic requirements. The technical soul of the CEB is its incredibly short, rifled barrel. Designed to fire sub-caliber projectiles with specialized aerodynamic profiles. While the Russians used long needles, Brazilian engineers experimented with smaller, high-velocity rounds relying on a precise spin rate for stability. This approach aimed to make the weapon feel like a standard sidearm, reducing the bulk of multi-barrel designs. Testing revealed a muzzle velocity of nearly 900 feet per second on land, but underwater performance struggled against ocean density. At depths beyond 15 feet, spin stabilization failed, causing rounds to tumble and lose lethal energy within 10 feet. Frequent jamming caused by saltwater buildup in the complex rifling grooves further crippled its viability for special operations. The project remained experimental as it could not compete with the brutal reliability and range of Soviet flechette systems. The CEB stands as a fascinating footnote in evolution, proving that unconventional logic usually wins beneath the waves. The AUM represents the pinnacle of Russian clandestine engineering, developed for sensitive Spetsnaz harbor sabotage missions. Its lethality centers on the .177 caliber SPS-M cartridge housing a 65-gram steel flechette. To achieve total silence, the AUM utilizes an internal captive piston that travels exactly 0.8 inches before locking, trapping 50,000 pounds per square inch of gas pressure inside. This mechanical seal prevents any bubbles from escaping the muzzle, avoiding detection by surface hydrophones or sonar. The weapon is remarkably compact, with an overall length of 6.8 inches and a weight of 1.9 pounds. Operating at a subsonic muzzle velocity of 950 feet per second, the AUM delivers surgical precision at close quarters. Its lethal range remains consistent at 25 to 35 feet, where the projectile penetrates a 3/4-inch thick marine-grade plywood target. The firing report is reduced to less than 70 decibels, quieter than a standard air rifle. Because gases are contained within reinforced brass, the weapon generates nearly zero thermal signature, essential for avoiding infrared sensors during night operations. It is a ghost-like tool designed for the precision of a scalpel. APS. The APS shattered naval warfare limitations, functioning as a full-sized assault rifle with a 26-round capacity. Its technical soul is the 5.66 mm MPS flechette, measuring 4.72 inches with high hydrostability. To overcome water density, the APS utilizes a self-regulating gas block that adjusts cycling based on resistance. At 16 feet deep, this machine delivers 600 rounds per minute, capable of punching through a .20-inch thick steel plate at 35 feet. The overall length of 32.3 inches with the wire stock provides necessary leverage for recoil management. Data shows the flechette leaves the muzzle at 1,148 feet per second in air, though drag causes rapid deceleration. At 16 feet deep, the lethal range reaches nearly 100 feet, but physics at depth is unforgiving. At 130 feet, the effective range is crushed to only 33 feet due to hydrostatic pressure. The smoothbore barrel causes rounds to tumble in the air, limiting land accuracy to 50 yards. Despite this, the APS remains the gold standard for underwater, proving automatic combat can be mastered in the crushing darkness of the abyss. QBS-06. The QBS-06 represents China's strategic evolution of the Soviet flechette rifle, optimized for modern combat divers. Chinese engineers replaced traditional steel components with high-grade anti-corrosive polymers and specialized alloys to survive high-salinity environments. This material shift is critical for operations in the South China Sea, where standard maritime firearms would suffer from rapid oxidation. The rifle utilizes a 6mm caliber DBS-06 dart, slightly larger and more stable than its Russian predecessor. This 5.8mm projectile is crafted from high-density tungsten, allowing a tight grouping of less than 10 inches at 20 yards underwater. The QBS-06 features an oversized trigger guard to accommodate thick neoprene gloves. The weapon weighs 6.8 pounds empty and feeds from a 25-round detachable box magazine. Muzzle velocity reaches 820 feet per second under the surface, providing enough kinetic energy to neutralize targets through reinforced gear. Its fire selector allows both semi-automatic and fully automatic modes at 600 rounds per minute. By focusing on material science, China created a refined instrument of naval warfare. North Korean Special Purpose Rifle. The North Korean Special Purpose Rifle is a mysterious variant of underwater Hwa-Luk recently surfaced during military parades in Pyongyang. Observations suggest a modified derivative of the APS, tailored for the grueling conditions of the Korean Peninsula's coastal waters. Its most striking feature is the oversized squared-off magazine, likely housing an increased capacity of 30 long needle flechettes. This design suggests a tactical emphasis on sustained suppression during amphibious landings or covert harbor infiltrations. Experts believe the internal gas block is reinforced with local steel alloys to handle the unique pressure curves of the North Korean 5.66mm cartridge. The rifle incorporates a folding wire stock and simplified iron sights, keeping dry weight near 7.5 pounds for diver mobility. The weapon delivers a lethal range of 80 feet at shallow depths. Its rugged construction focuses on reliability in freezing saltwater, where mechanical tolerances must be precise to prevent terminal jamming. The existence of this weapon confirms North Korea maintains one of the world's best-equipped maritime special operations forces. It serves as a reminder that specialized engineering remains a lethal threat in the silent depths. ASM-DT-01. The ASM-DT-01 emerged as a pivotal breakthrough in dual-medium combat, solving the historical failure of underwater rifles on land. Engineers designed this hybrid system with a unique dual-feed mechanism accepting two distinct magazine types. When submerged, it fires long 5.45 by 39mm MGTS flechettes from an oversized translucent magazine. Upon surfacing, the operator slides the magazine well forward to accommodate standard AK-74 magazines with conventional ammunition. This versatility allows the rifle to maintain a lethal range of 80 feet underwater while providing a 300-yard effective reach on the surface. The internal gas system adjusts to handle differing pressure curves of air and water environments. The barrel features shallow rifling that stabilizes standard bullets without obstructing smooth-bore flechettes. Despite its 18.9-inch barrel, the weapon remains cumbersome as divers must carry two entirely different types of heavy ammunition. This logistical burden often limits agility during rapid transitions from sea to shore. The ASM-DT-01 proved a single rifle could dominate both worlds, paving the way for more streamlined amphibious systems. ADS two-way. The ADS two-way represents the zenith of amphibious firearm evolution, utilizing a compact bullpup layout measuring only 26.9 inches. This design moves the action behind the trigger, providing a full 16-inch barrel while remaining highly maneuverable in tight underwater corridors. The true magic lies in the PSP 5.45mm ammunition, featuring a flat-tipped projectile for supercavitation. As the bullet travels, the flat nose creates a vapor bubble envelope, reducing skin friction and allowing it to glide with minimal resistance. This allows the diver to use one single magazine for both environments. Eliminating cumbersome gear swaps, the rifle achieves a cyclic rate of 800 rounds per minute and includes an integrated 40mm grenade launcher. On land, the ADS two-way matches the accuracy of a standard AK-74 with a lethal reach of 500 yards. Underwater, the supercavitation effect maintains stability up to 80 feet at shallow depths. An adjustable gas regulator ensures reliable cycling, whether submerged in high-density saltwater or standing on a dry beach. This weapon is the future of naval special warfare, a clinical solution to the most difficult engineering challenge in firearms history.